What's going on, everybody? It's your boy, Spooky Software, back for another one. It's been a few months. I apologize. Just been busy with real life stuff, thinking about other things, but I'm back. I'm excited. I got a really cool video together for you guys today. Today we're going to be talking about reactivity, right? And actually, we've talked about reactivity on this channel already. I have a video called something like building observables from scratch. And so one way you can do reactive programming, if you will, is using a library like RxJS or RxJava. These are kind of using streams and what they call observables. Today, however, we're going to be talking about a slightly different kind of reactivity, which just uses slightly different primitives, but maybe at its core has a lot of similarities. And I think that's where this kind of language comes from. So today we're going to be looking at some code, and the code is written in a UI framework called SolidJS. It's written by this guy, Ryan Carinato. I hope that's how you say that. Basically, everything we're going to be talking about today is inadvertently his idea. I'm not saying that he invented reactive programming or anything like this, but he's a very prolific writer and sort of advocate in the community for this idea of reactivity, and he built an entire UI framework around this idea. But one thing I hope that kind of comes out of this, falls out of today's discussion, is that these ideas are actually super pervasive. And he's not the only one. Maybe he's most vocal for like this one core concept, and he really thinks this is sort of all you need, but like it's all over the place, right? We've already discussed RX, JS and these kinds of things. And again, that's a slightly different kind of reactivity. Maybe even in like the functional programming languages, you have like FRP, functional reactive programming, which is again, a slightly different flavor of similar kind of ideas. But today we're going to be talking about using SolidJS as our sort of archetype, our exemplary library, right? So there's kind of three core concepts in reactive programming, at least in these sort of JavaScripty libraries that we use to make UI. There's the first thing, which is called signals. These are kind of your state holders, and really they're just two things. There's some way to set a value and some way to read that value. This in and of itself is probably completely useless, because why wouldn't you just use like a variable or something? In Solid, it's very explicit. So you create one of these things, which is a set of two things. One is a getter. So calling this function will read the current value, and then at some point later, you can set the value by calling the setter and passing a new value. In this example, it's really straightforward. Console logs is 0 because that's the initial value, and then after you set it, if you read it again, it'll be 5, right? This in and of itself is not very interesting. But what makes it interesting is sort of the second concept, which is generally called a reaction, right? So in Solid, a reaction is created using the create effect function, not unlike a use effect in React, if you're familiar with this, but very different in practice. Which is basically saying you pass to create effect a piece of code, a function in this case, that you want to run whenever a signal that code is subscribed to changes to run. And we'll see exactly what that means a little bit when we get into this code, but think of it just by reading this code as anytime count changes, I want to console log what the current count is. And he has some console logs to demonstrate this, but I'll do this in the browser because I think it's a little easier if we do it together. And finally, there's kind of a third concept, which is in some sense kind of optional. I think if you have signals and a counterpart reaction, you don't need this, but and maybe some simpler reactive systems, some simpler reactive libraries will sort of end there. But there's kind of a third concept called a derivation, or in Solid they might be called a memo, or maybe a computed or a pure, which is basically kind of a middle between a reaction and a signal, which is to say it also can subscribe to, here it is, here's this create memo. You pass to it a function just like you do an effect, and it will subscribe to any signals that it utilizes. So you can see we have one for first and last name, which is exactly what we will be using in our example in a moment. But full name is a getter itself. And that getter's value will change whenever one of its subsequent signals changes, right? And so we can use this full name inside of a create effect to subscribe to it just the same way as we can subscribe to a signal. It's kind of like this middleman, if you will, that kind of ties together maybe a bunch of signals together in some way, and then gives you a new signal that you can subscribe to, right? And I just want to look at this picture real quick. It's not quite clear which color means what, but for our purposes, we'll call blue signals and green derivations and red effects. And essentially, it creates this graph, right? So what I mean by that is so these blue value are signals, they have values, right? And they may be subscribed to by one or more green and red things. So in this case, this blue value is subscribed to by both this red effect and I'm sorry, it's the other way around. This red effect is subscribing to this green derivation and this blue signal. And so what that means is at any point in time, if either one of these two values changes, we know that the red effect needs to be run again. And same here, just as another example, this signal is being subscribed to by this derivation and this one as well. So, both of these values will be updated to this one. And it can kind of go through these chains, right? So if this value updates, then that means this one and this one update, which means this effect gets run and this derivation updates, and also this signal may be run. And so that's really at its core what a reactive system is it's kind of a manager for these dependency graphs of computed values. And most importantly, potentially, is that the relationships between these things are relatively declarative. They might be explicit, they may be implicit, depends on your particular library, doesn't matter. The point is that we sort of set this graph up and then we let the system go. Right, and these setters, these blue values will update periodically as state changes, and everything just sort of falls out of that. So let's jump into some code and see how that kind of works out in practice. So here I have a little thing I'm running here. So we'll just ignore this commented code. It's actually pretty straightforward, right? Just like in the code we were reading a second ago, I got two pieces of state, two signals, right? I'm using this SolidJS library. I'm importing my three primitives, essentially, or the ways to create my three primitives, right? And I'm utilizing them, right? So I'm console logging that I'm setting into effect, and I'm saying anytime first name or last name changes, I want a console log to the screen. The user's name is this, right? And so let's actually look at this in code. In its output. So again, we come to this page and, we set up that effect. First, my name is Eric Butler. And then at some point later, you can see that it console logs again, Eric Kim Butler. Let's look at this code. That's because after 2 seconds, I called this setter, right? And Eric got married, and the code ran. That's really all this is, right? Like that's sort of the core concept is we had some state, some setup code, and then like from this point forward, this semicolon, if you will, on line 9 forward, like anything could happen here. It doesn't really matter. Whenever these setters are being utilized, my effect is just going to automatically happen. Everything is going to remain sort of in sync, right? And we'll see a little bit later how being in sync is really important for UI. But I also think that these concepts can be applied to more than just UI libraries. I think they're very popular in JavaScript UI libraries, but I think they can be used elsewhere. So here's another example. Let me uncomment this, right? I'm actually going to write this by hand. We'll go through it together, right? So I have this system, right? I actually do this for a day job, right? Where we have this idea of a user being compliant, right? And so maybe the way in which they are compliant is they have a license, and that license expires on some date. So here you can see I have a piece of state, I have a signal, and I'm saying that is my license expiry date, right? So you can see here my license expiry is sometime in 2025. So I'm recording this in 2022, which means that I'm currently compliant. My license hasn't expired yet. I'm also modeling something else, which is right now. I'm modeling now as a piece of state. So I initialize it as, whatever it is. And I say, hey, every second, I'm just going to like set the current now to something else, right? And so I can do something like this. I can say, well, I want my system to, whenever this person goes non-compliant, meaning their whatever current time it is in the future from their license date, that means they're expired. So I can do something as simple as create an effect. I can say, if you're not compliant, and we haven't written this function yet, but that's okay. If you're not compliant, I'm going to send an email, which is saying something like, dude, update your license, please. And is compliant is really straightforward. So I wrote it as a function. So I'm just going to make a silly function, right? Which is saying something like now is in the past from license expiry. I got to spell license correctly. And I just realized that I spelled it wrong down here. So we'll fix that. Okay, cool. So this is like kind of dumb code, right? I have this function. It's just a regular old function. And I say, hey, is now in the past from license expiry, which means I'm compliant if this returns true. So if that's the case, let's see what happens. We got to go back to the browser. Okay, well, nothing happens because I didn't console log anything. So let's add a little bit of debugging. But this is kind of a good sign because, you know, I'm only doing something. I'm only console log. I'm only sending an email if I'm not compliant. But let's just like, you know, for debugging purposes, let's just make sure, you know, everything is happening as we expect, right? And for now, I'm going to comment out this. I don't think we need that anymore. So I'll just say is compliant. Okay. And we'll get rid of this one as well. Okay, so sorry about that. Okay, so we can see here that we're saying, hey, it is compliant is true, right? But like this is actually working correctly, but not quite exactly what I wanted, right? So you can see that every second this thing is updating. Like so, Firefox is like condensing the logs because it's the same log every time. And every second we are checking, right, if I'm compliant or not. And since it's always true, we never send the email. But like let's like copy this code over here because it's useful, right? We'll go down here. We'll say after 2 seconds, we're gonna set license expiry to new date. We'll say right now. So we'll refresh this, right? It starts as you know you are compliant, but eventually it says false, and it's still false. But like we've run into a problem, which is that we're sending emails like all the time now. And why? Let's read this code. Why is this happening? Well, this effect is subscribed to any signal that comprises its computation, right? And in this case, it's comprised of both now and license expiry. So again, it did change when license expiry was updated. We did run this code again. But it's also running every time now updates, which is every second. And so here's where I'm going to use a derivation, right? We didn't really talk too much about this, but here we go. Create memo. All I'm going to do is wrap this in a create memo and refresh my code. And suddenly it says is compliant true, and then is compliant false, and we send one email. And you can see it's not repeating anymore. So what changed here, right? So basically these memos are a way to subscribe to signals, recompute a new value that also can be subscribed to, but it also has an additional constraint that if the computed value itself is exactly the same as what it was the last time, there's no reason to update any subscribers, so it just doesn't do that, right? So again, create memo is subscribing to now and is subscribing to license expiry. And this effect to send an email is only subscribing to is compliant. But there's this additional like nicety to derivations where, yes, this function is running every second because now is changing, but the result is false or starts as true and then becomes false. And so once it becomes false, any subscriber is compliant isn't going to run again until the actual value itself changes. So because it's false, it's staying false, there's no reason to update any downstream subscribers. So this is really the core of the whole system, right? We have these three kind of primitives, and we have a way to sort of set up declaratively, right? So here's some declarations that we're sort of setting up right here for managing compliance and license expiry. And it doesn't matter where this code is. Like in this simple example, everything's in one file, within 20 lines of each other, but we can imagine that this is like somewhere else, way else in the system, somewhere in a totally different file, in a totally different controller, maybe like, it's a REST API that like the user updated their license expiry to be to today, right? And they wrote to the database, and this code right here is just sitting there sort of waiting for that to happen. And once it does, it knows what to do in response. It reacts, right? And this kind of scales, right, in pretty interesting ways, I think. It also inverts the control, right? Like, it's not the responsibility of the code. Like I said, this could be anywhere. And it's basically just this one line. It's not the responsibility of the code that updates license expiry to also go handle compliance and also go like send emails and these kinds of things. It's just setting the expiry, and it expects that like anything that falls out of that new expiry has already been set up elsewhere in the system, and that part of the system knows how to manage itself. So I think this kind of scales in very interesting ways. Let's actually turn our attention to UIs, because I think UIs are sort of the classic case where this shows up. And I've already built something that we can kind of look at together. So I'm just going to change this to... And let me refresh this. Beautiful. I don't think we need this console anymore, but essentially what we have here is a really simple page, right? So it's got a button here, and every time I click the button, this count updates, right? And it's also a game, because eventually something happens. When I get to 5, I win the game, right? And so there's a couple of things that happen on the screen, right? So every time I click this button, the count updated. But also there were some related things, but in different places that changed. As soon as I got to 5, first of all, we showed an alert to the user. And also it's a little hard to see perhaps on the recording, but I've also changed the document title to "You're a winner," right? And so as soon as I change it back, as soon as I update it again, and I'm no longer a winner. The goal of the game was to get to 5 and nothing else. So let's actually look at the code, right? So here it is. If you've seen React code before, this probably feels relatively familiar, but it's subtly different in maybe some explicit ways. Like maybe if you're used to use state, you would recognize kind of the signature of this line, but instead we're calling you create signal. This is solid code, as I said, but it kind of does all the same things we just did in our simple example, except it's utilized to do UI stuff, right? Utilized to do DOM things, right? So again, we have a count. We initialize it to 0, and we have a setter, right? And at some point in a click handler, whenever we click this button, we're going to take the current count and increment it by 1. It's sort of the core write operation that our application does. And if you notice, we're actually using the count reader in a bunch of places, right? We're using it here on the button, right? Because we got to pass in the current count. We're also using it in the alert itself, like what is the current count? We're utilizing it inside this derivation, inside this memo, and we're saying like, hey, if the count is actually exactly equal to 5, then this person is a winner. And then we're using this derivation and we're subscribing to it in a bunch of places. Once explicitly with create effect, we're saying, hey, the document title, if the person is a winner, needs to be something special. Otherwise, it can be the original title. Also, we're subscribing to is winner. We only want to show the alert, when this is truthy. So this looks very, very straightforward. However, it's a little unexpected. I can kind of prove something. I can kind of prove it's a little weird by doing something like this. Rendering reactive app. I'm just going to console info that we're rendering. Okay, so we do it once, right? That makes sense. The app initializes, we set up our app, we render this component. But if I click this, I can click this as many times as I want. even when that winner thing turned on, and you notice there's no additional console logs. And so this is different than a React component, for instance, in that the reactivity is very fine-grained, which means that these subscribers are actually the only thing that ever changes, right? So this code actually runs once. It gets set up once, the component mounts, if you will, and all of the relationships are created declaratively. All of the relationships are declared, and everything is subscribed in the way that we just described in the simple example. But then it's done. There's nothing else to be done. All of the setup is there, and the system just runs from that point forward. So this click event handler happens, and all the places that are subscribed to count or inadvertently to isWinner just automatically happen, and there's no reason to ever re-render. That's actually useless work at this point because we know exactly in a very fine-grained way where subscribers are and which subscribers we need to run. So again, we know we need to run this piece of code when isWinner changes and for no other reason. And this will never ever run unless isWinner changes. And isWinner changes only if count changes, and only if that count changes from some value to 5 or from 5 to some other value. And so I can kind of prove this to you in another weird way. So what I'm going to do is do something like this. First of all, I'm going to take this, I'm going to say text content equals props.count. So again, this is the implementation of my button, right? And so I've written it a slightly different way. Instead of using children, I used text content. And again, the app works the exact same way, but I'm getting closer to something that resembles DOM, and I'll explain why I'm doing that in a moment. But just note that, okay, props.count is one of these signals. We know that. And Solid knows, hey, when props.count changes, when this count changes, I need to update the text content to the new value. I'm going to do something else here that's a little weird. So first of all, I'm not going to use the text content at all. I'm just going to do something like this. I'm going to say button L equals that thing. And then I'm going to put that button L in here. And if I refresh this, it's broken. And that's because we're no longer setting text content. Even though actually you can see the count is changing, we're not subscribed to that in the button elements text anymore. But I'm going to do it. I'm going to do it a little bit of a strange way. I'm going to say button L dot text content equals props dot count. And then I'm going to refresh this, and all of a sudden my code works again. And so why does this work? Well, it's exactly the same principle we've been talking about this entire time. It's, turtles all the way down, is that we created an effect and we said this effect keeps track of all of the things it subscribed to, including props.count, and it knows I need to rerun this line of code anytime the count changes. And we notice that we're actually doing regular old DOM APIs. It turns out the button element, if I console log it, and I will, just to prove my point, oh, didn't mean to open a new tab, is actually just a regular button element. And in fact, it is that button element. And so you can see I'm console logging it every time I change the count, and it's just a button. So I'm allowed to say text content and do an assignment. And it turns out that this is exactly how Solid works under the sheets. It doesn't do anything other than create effects, subscribe to signals and or derivations in the places that are appropriate, and either update text contents or inner HTMLs, or maybe in some cases some attributes, right? So I can do something like, I can say, maybe I want to do something like BG, let's do green 600. I like that. I'm going to add a special class when props.count is greater than 5. All right, so let's see what happens here. If I do this, eventually I get to 6, and all of a sudden my class changes. My class attribute now has inside of here, it's got this BG green 600. And that makes sense. So props.count is a signal, and this classless attribute like subscribes to the value, recomputes this thing, and says like, if it's truthy, I'm gonna add this class, right? And I know how to do that. I can call button l.setAdder, right? Or in this case, classless.add. So I just wanna sort of illustrate that this is like incredibly efficient. Like there's no, for instance, compared to React or something like that, there's no virtual DOM here. Because components only run once, it's totally efficient and even desirable to actually create real DOM elements. This button element is the button. We create it once on setup, and then we draw relationships, right? We draw relationships between the text content of that button and some observables, some signal, and everything just falls out of it. And when we write code like this, or even when we write code that's like this, you know, we just put props.count in here. Under the sheet, all Solid is doing is using create effect to put things in the actual DOM. So anyway, if you look at sort of performance numbers, especially in compared to something React, one of the reasons that Solid is so performant is because of this fine-grained reactivity, right? When count updates, only the effects that are subscribed to count, or maybe derivations that are also subscribed to count, will run. And that's it. There's no reason to ever recreate anything. There's no reason to ever re-render anything. Unless, of course, you know, one of these things changes and destroys something. Like, for instance, in this case, if isWinner becomes truthy or falsy, we're going to, you know, create a winner display component and then maybe later destroy it. So I just kind of want to end. I will, of course, put all this code up online somewhere on GitHub or whatever, and I'll link to it in the description. But I just want to kind of end talking about these things. So these are like super pervasive. Even though reactivity is like first-class citizen in SolidJS, it's actually all over the place. So this is a library called Knockout.js. It was like popular maybe 10 years ago, and they had something called observables. And this was, you know, reactivity, right? So what they had was they had some way to create an observable. This would be like the exact same thing as create signal. And then they had ways to subscribe to it, right? And this would be the equivalent of create effect. You're saying, hey, anytime the person's name changes, I want to run this thing and make an alert. Here's an article that's talking about MobX, right? Which is a very popular, what they claim to be reactive library for React.js. And so again, this picture down here looks very familiar to us. So these state things, which are, you know, our signals, and then perhaps those update some computed values, which are our memos, our derivations, or whatever you want to do. And then of course, those can trigger reactions, right? Effects, changing text content, sending emails, console logging to the screen, whatever the case is. Here's an example of refs in Vue.js, right? So a ref is a signal, and the syntax is a little different, the API is a little different, but essentially count is a signal. It has a way to read the value, and it has a way to write the value, which is just a setter. And of course, you can utilize those refs in things like computeds. They call their derivations computeds in Vue. But again, this value +1 will automatically update to be one more than the count anytime count changes. It's the same exact thing. And again, here's their watch effect, which you guessed it is a reaction, right? Anytime count updates, suddenly we're console logging the latest value. And here's one more. I want to take a look at this one. So this is a popular library, or becoming a popular library called Svelte. And Svelte is probably the most interesting from like it's extremely implicit. And so what I mean by that is what they do is they basically have a compiler that reads your code, and it turns regular old lets into reactive code. So let is a variable, right? There's a variable called count. And even though there's no explicit syntax to mark it as such, this is a signal. So what happens is anytime you update that signal, right, anytime you click this button, not only does this value update and any place that is subscribed to it, like for instance, this button is now the current count, but you can also use the $sign, this is a $sign label. In JavaScript, you can have labels. And so it's saying, I want you to also update the doubled computed, the double derivation, anytime anything on the right-hand side updates, in this case, count. And of course, you can also subscribe to a derivation through another derivation. So anytime doubled updates, I'm going to take that value and double it to get quadrupled. And again, I can, use an effect. I can subscribe to that in the UI. And here we go. So not only do we have the count, we have double that, and then we have double that to get quadruple. So I just kind of wanted to end on this note, just talking about how pervasive this is. And I think it's a really powerful idea to sort of declaratively set up some code, set up some initial state, set up some relationships between that thing. And we talked about this at the very beginning. It doesn't matter where this handler is. Everything's going to stay in sync. This you can update the count in like some totally unrelated piece of code. You can update it, maybe 6 hours from now, a year from now. It doesn't matter. All the relationships are already declared up front, and everything sort of falls out of that very naturally. In UI, we've seen how this can be extremely performant, right? In the case of Solid, Solid is like one of the fastest libraries out there with UI, and that's partially because of how fine-grained it is. Things run once, things are set up, and then only the parts that need to change actually change when they do, right? So I hope you enjoyed today's video. I know it's been a while. Let me know what you think in the comments, of course, and I hope you have a great day.